All right, welcome back to the video. My name is Piyush and this is day 30 in 30 days of AWS Terraform. Yes, this is the last day. Finally, we are here after so much of effort, so much of troubleshooting, and after so much of wait. I hope you are having a good learning experience and I hope you would have implemented all these projects, all these concepts by yourself, and you have completed the task given in each of the day videos challenge. So this is the last video. So we'll be implementing this. So we'll be doing drift detection using GitHub Action and Terraform, which is a real-time end-to-end project. If you have implemented this by yourself, you will understand end-to-end Terraform. You will understand end-to-end GitHub Actions. Although GitHub Actions is not something that we will be covering in this video in depth. Like I will walk you through everything, but we will not go like from the very basic or from the in depth. If you need a separate dedicated playlist for GitHub Actions, let me know in the comment. I can start working on it. But I want to restrict this video within 1 hour or so. I don't want to go above 1 hour because after that you guys will feel bored and then you will just skip the video. So there is no point of doing that. Plus, I think this series is dedicated to Terraform and we have covered all the related concept related tools. But if we stick to the Terraform, that will be better so that we can keep GitHub Actions aside. But because it's a requirement for this video, we'll be covering that as well, right? So we'll be covering the end-to-end drift detection using GitHub Action and Terraform. Oh yeah, I was saying that if you have completed this project by yourself, so you should be able to understand end-to-end GitHub Action, end-to-end Terraform, and how does a drift detection work real time in an organization. How would you create pull request? How will you merge the changes and so on? So do not miss this project. Watch it till the end and try to implement it by yourself. Yes, you must be wondering what about the results of 30 days of AWS Terraform winners. Yes, let me finish the recording. I'll let you finish all the tasks, and maybe after a couple of weeks I will announce the winners. So there are like 700 plus submissions already pending for us to review. There is a lot of work, so give us some time and we'll be reviewing it. But this time we'll be doing some strict review because earlier when we did the review there were a lot of mistakes, like people pushed AI generated, like completely AI generated blocks and diagrams, and like the requirements of the task were not fulfilled, right? So we gave them chance to update it. Some of you have updated, some of you ignored it. So this time, because there are a lot many more submissions pending to review, we don't have time to review and then get back to you and doing back and forth. So if the requirement is not fulfilled as per the task given, we will be rejecting that particular issue. I hope you understand this, right? So okay, let's get back to the video. So what are we doing? Okay, so this is the flow. Let me explain this flow, but this is the project that we'll be implementing. Okay, so what this project is, let's just zoom in a little bit. This is what we have covered earlier as well, so you might be familiar if you are already following this series. So it's an AWS VPC with the two public subnet, two private subnet. In public subnet, we have two NAT gateways so that EC2 instances in the private subnet can get access to the internet to download updates, to download the Docker images and so on, because we'll be downloading the Docker images from Docker Hub over here, right? Which is like a public Docker Hub registry. So these EC2 instances inside the private subnet need access to that. So that access is securely done via NAT gateway. We should not be putting these backend servers in public subnets. That is why we did that. And then they are part of an auto scaling group and they span multiple availability zones for high availability. As you can see, if one goes down, another will spin up in the different zone. So auto scaling group has been set with minimum one, desired two, and maximum five EC2 instances. Okay. This, like we have seen this earlier as well, and this we have worked on it earlier as well. So I'll just move on. Okay, so this is the project, the end-to-end project that we have. Okay, so you have a GitHub repository which has your infrastructure provisioning code, your Terraform code, which is over here, right? day 30 folder, and then there is a code folder. Inside code folder you have scripts and all the Terraform files. Now when a developer or the infra team make the changes in the dev repository, in the dev branch via pull request, so it will trigger the GitHub Actions workflow. Okay, so what workflow we have? If you go to the root of this repository, we have three workflows created for this particular video, which is inside the workflow folder, and it is terraform.yaml, which is for infrastructure provisioning and maintenance, drift detection to detect the drift and make the suggested changes, and destroy to destroy the infra. Now these all can be executed manually as well, and this is what it says. It can be a manual trigger and a cron trigger, right? So cron trigger is the pipeline will keep checking if there are any changes in the infra. So if there is any drift detected, then it will uh, execute the changes. Otherwise you can manually trigger it. Or if there is any changes to the code, then also it will trigger the pipeline. So what are the workflow steps? First, it will check out the code. Then it will determine the environment based on the branch that you have selected. If you have selected the dev branch, it will set the environment variable for dev environment. If you have triggered production, if you have merged the changes on the main branch, then it will determine prod as the environment, and it will set the variables and credentials accordingly. Then it moves to the next step, which is Terraform. So Terraform setup, because we'll be running that GitHub action on an GitHub runner, which is hosted on GitHub. So it needs that Terraform installable. So that's what we are doing over here. Then init, backend, plan detection, and so on. Now here is the part of drift detection. What it does, it will compare the plan, it will compare the output of Terraform plan command with what we have over here in the state file, right? So it will compare if there is any changes in the Terraform environment. Sorry, it will compare the changes of your code that is there, right? That is there in the GitHub repository. It will compare that changes with the Terraform plan output. So if there is a mismatch, that means someone has made some changes on the environment directly. So it detects the drift. And whenever there is a drift detected, so it will do these things, right? So there is this decision gateway. So we have some control condition. I will show you that as well. So based on that, it will check if there is a drift detected. If there are no drifts, that means uh, your environment, your desired state is equal to actual state. Or if the plan failed, then it will just exit it, right? So if there is a drift detected, what will happen? So let's move ahead over here. So if the drift is detected, then it will apply the changes again from the code, so that the changes made manually should be overridden, right? It will apply the changes, it will update the resources in the environment, and then it will verify the fix, and it will send the notification via Slack channel, Slack alert, because we have set this, and also it will close the GitHub issue. Okay, and it will like fix the status. Yes, that's the part of it. Now if the plan failed, that means the workflow will exit, because the plan failed, there is some issues on the files or the configuration code or whatever. If there are no drifts, it will not take any actions, and it will just update that in the summary report. Okay, and yeah, so that's it. Over here, when we configure the AWS credentials, it will authenticate to the AWS environment, like dev environment or prod environment, based on what you have selected, based on the environment that has been determined, based on the branch that you have checked in your code to. Okay, so that's the like the high level architecture of it. What are we going to do? Let's move ahead to the GitHub repository so that I can show you. All right, let me close these things. Okay, so if I go to, yeah, first let me just, okay, I'm not gonna walk you through the code, because code is something that we have used multiple times earlier, so it will just waste your time and I don't want to do that. I'll just walk you through the some prerequisite and some different things that we have done over here. Okay, so for the backend we have created two files, one for the dev backend, which is this, it's a .html file, something that we have not used earlier, but this is considered this something like terraform.tfvar files but for the backend. Okay, and it's in the form of key value pair. Okay, so we have created separate bucket for dev and separate bucket for prod, right? And actually that's the like the file and folder name, bucket name is over here. So we are using same bucket but different files inside that bucket. You can use separate bucket as well, that's not an issue. And we are using the log file feature. DynamoDB log file state file has been deprecated, so this is what we are using. And rest of the infra, I think it's same. In the script folder you can set up your backend from here, so you can run this command to set up your backend. I already have the backend set up, so I don't have to do it, and it does basically the same thing that we have been doing in almost all the videos. Okay, now make sure you update these files, otherwise it will try to find these buckets and it won't find it, it will throw the error and then you will fix it again. So make sure you update these two files. And then there'll be variables.tf where you can set the default values. Okay, and okay, then there is backend.tf, but it has been commented because these values we are using from these files. Okay, then we have, okay, so this is backend, this is user data, so that it's basically doing installation of Docker on the virtual machine on the EC2 instances and then spinning up a Django container. And this Django is basically a web app, an e-commerce web app. I will show you that. And that let me show you in fact. So this web app has been exposed with an application load balancer. So this is what you will see once you log into the DNS. So does it show the load balancer? Yeah, over here it should be there, right? So application load balancer over here. Okay, so now let's go back. This is the load balancer. I have provisioned the infra before the recording because this is what we have done multiple times. I don't want you to go through that again because in this video we are specifically testing for drift detection, so that's what we'll be focusing on. Okay, so let's talk about drift detection. What we need to do in days 27, I will show you how to create and how to trigger GitHub action. So we are using the same. In the root of the repository we have created three files: Terraform YAML, drift detection, and destroy YAML. Okay, so let's talk about terraform.yaml. So this file name is terraform CI/CD. This is the main file which will trigger the workflow, okay, whenever you make any changes. And how it will trigger? On push of these two branches, if you push on main or dev, then it will trigger this workflow. Or if you create a pull request on main and dev branch, right? I mean, when the pull request will be accepted, then only it will be triggered. Now, based on the branch that you have set, it will set, I will show you that later on where it is setting the variables. I think it's over, yeah, you see over here. If the branch name is main, that environment is prod, and set this to this variable and this variable. If the environment is dev, oh sorry, if the branch name is not main, that means is dev, which is in the else part. So environment is dev and set this to these variables. Okay, now let's go back over here. So we covered till here. So this is the trigger. Then we have permissions. Permissions is because the GitHub runner bot or the tool or whatever you want to call it, it needs some permission on your project, on your GitHub, to comment and to write the pull request details, right? So it should have permission to read the content, and it should have permission to write issues. That means it should be able to write comment on the issues, close the pull request, close the issue. So it should have that write permission, and that's what we are providing. Now these are the environment variables we are setting. So use the AWS region as this, Terraform version as this. Then here's the job. Job is what in GitHub Action? Job is something that runs on an agent. Agent over here is GitHub runner. Okay, so let's say if you are familiar with Jenkins, in Jenkins you create Jenkins agents or Jenkins slaves. Okay, so that slave is nothing but an executor on which you run something, or you can call it a build server, a CI server, or a CD server, right? You can call it with many names. So similarly in GitHub Action, it's a runner, it's a GitHub runner, and that's how we are running any job on that. So jobs, this is the job name, which is Terraform plan. Okay, and runs on Ubuntu latest. We are using Ubuntu as the base image for that runner, and then default run on this directory because like this repository has day 30 videos and we just want to run the code on this directory, which is for day 30 inside code. So we are setting the working directory, and here's the output variable, like environment, which is from this step, whatever environment variable comes as an output, set this to the like environment variable. Okay, then the next step, so that's the first step, which is basically, actually that's not even a step, this is just some prerequisite settings. The first step is the checkout. Okay, in the checkout we are using GitHub Action is doing checkout of your Git repository. Then determine environment, this is what we have already seen. If the event type is pull request, then branch name set this, else branch name set this. Okay, and set the environment variable based on the branch. Then echo deploying to environment, right? Then configure AWS credentials. AWS credentials has been set in the GitHub Actions, and where it is set. So if you go back to the repository, which is over here, and go to settings of this repository and scroll down to environment and scroll down to okay, here are the environments as well that you need to set, dev and prod, right? So just like it should not have a lot of details, so which this is dev environment, and prod should have this thing. Prod should have a required reviewer so that we have a manual approver before the prod deployment. Okay, and we need to set secrets over here. Inside security you see secrets and variables and actions. Okay, so here are three secrets that I have set. One is Slack webhook URL, AWS key ID, AWS secret access key. We are at the end of the video. I am pretty sure, I'm 100% sure you know how to get these values now. Okay, so I'm not gonna bore you with that. So the other thing is Slack webhook URL. Slack webhook URL, you can just go to let's say Slack webhook and search for this api.slack.com. There is an app which is uh, alert or whatever your app is. So basically you have to configure this app which is of type alert, and inside that there'll be a section called incoming webhook. Click on that and create a new webhook. Copy the webhook URL from here. Okay, so this is the webhook URL which is what I've just created, and you go back over here and paste the value in this secret. Okay, so this is how we are setting all these variables, and this is how it is getting the value from. So AWS access key and access key ID, it is getting from secrets. What are these secrets? These are the secrets of GitHub Actions which we have just seen. And AWS region value, it is getting from the Terraform environment variable. Now the next step is set up Terraform. Okay, and it says name this, uses this, that means use this package of Terraform to install that, right? With Terraform version, the version that we set in the beginning, Terraform wrapper equal to false. Then Terraform init, what we are doing, Terraform init reconfigure backend configure backend hyphen environment name.html. You remember we have two files, one for dev, one for prod. So we are initializing over here based on the branch that we have set. So you see there are a lot of places where we are dynamically setting the values. We are not hard coding any value, right? So it should be able to detect the value of the environment, the value of the branch, and based on that it set all the things. Okay, So the next step is Terraform format check. We are doing a Terraform format check for any formatting issue. We are using Terraform validate for the syntax validation and all. Then Terraform plan. Now what we are doing, Terraform plan, output TF plan, right? And then we are moving that into a file called planoutput.txt. So basically output of Terraform plan with some formatting, and we are putting that into a text file. Now what we say is over here comment PR with plan. That means if the event name is pull request, so use the GitHub action GitHub script and set the GitHub token. You can like it will automatically take the GitHub token from GitHub. And then there is a small JavaScript code over here. What it is doing, so it is importing an FS a JavaScript package for file system, right? And what it is doing, it is doing a read file sync. That means it is reading this file asynchronously, which file planoutput.txt asynchronously in this format. Okay, not in the binary format, but in this format. And once it completes, it set the value of this variable as plan output. Okay, so now we have the content of plan output, which is Terraform plan output inside this variable. Okay, and then we are setting another constant, which is output, and in that there is like a string which says Terraform plan for this should be printed on the screen. Then there is some text like HTML text sort of, right? Details, summary, and so on, format, validation, plan. This will be visible in the logs and on the UI, so don't worry about it. Then Terraform plan status. If the Terraform plan is failed, then exit one. That means exit the pipeline workflow should be failed. If it is success, then upload the plan, the file that we had, upload that file with the name tfplan-dev to this directory. Okay, and keep it for 5 days for retention, right? So we are now uploading Terraform plan to the repository. Now Terraform apply. So what we are saying, if GitHub event name equal to push and Terraform plan dot result equal to success, then again run on this particular runner and on this working directory using this environment. And what are the steps? Check out, determine environment, configure credentials, same thing, right? Set up Terraform init using the same backend file, then download the plan. Now we are not running TF plan, it's already been done. So now we are just downloading it from where it was uploaded earlier. And now we say if this is just a validation. If the plan exists, then do this. If the plan does not exist, then no plan found, and infrastructure may already be up to date. It's just a validation check. And here we are applying the changes. So what it says, if plan exists, again another additional validation, then run this command Terraform apply auto proof with the plan that we have downloaded. Okay, and no changes to apply. If plan does not exist, then no changes to apply. Infrastructure is up to date. And output infrastructure info, which is like we are just echoing some of the text and so on, right? So this is your terraform.yaml, which will make the change, which will update the change and so on. Now this is important, which is drift detection. It's a long file, so I'll just walk you through with the important steps. First is when it will trigger. Either you can run it manually, and it can also be scheduled as a cron job. So this is what we are doing. Trigger on schedule, cron syntax run every minute, and you can change the syntax as well. I mean, you can change the frequency as well as per your need. But 1 minute is too much for a production environment. Maybe 10 minutes is ideal for prod. It totally depends on your organization settings, right? And also we are saying workflow dispatch, that means allow manual triggering. Now permission, again it should have some permissions. Environment variables are Slack webhook URL and AWS region. So Slack message, it will only send when it will detect some drift, and it will send the message over there. We'll see that. Then jobs, the job is drift detection, run on Ubuntu and run on this directory. Steps is checkout, determine environment, which is based on the branch, configure AWS credentials, then set up Terraform init, Terraform plan. Okay, so here is the logic for drift detection inside Terraform plan. What we are saying, Terraform plan detailed exit code is equal to plan output, okay, and all the error to the dev null, like all the errors to the same file, like std out and std error to the same file, plan output.txt. Now we are checking the exit code. See, if the Terraform plan fails, so the exit code is something other than 0, right? So this is what we are checking. Echo exit code will set the exit code based on whatever it is, and then we cat the plan and then exit 0, so it should exit after that. Oh, it should continue after that, it should not fail the step. The next is, let's analyze the drift. If the exit code that we got from the previous step, which is how can we check steps, so this is the step, right? Dot plan, which is the id of the step, dot output, which is the output variable, and what is the variable name? Exit code. So steps.plan.output exit code is equal to 2. That means it's not successful. If it's not 0, that means it is not successful, and if it is 2, um that means we need to perform these actions, right? What it is checking that if it is 2, that means there is some change in the file, like it doesn't match, like the Terraform plan doesn't match with the. Okay, let's check what this command does, just to show you. So if I run Terraform plan hyphen help, I'm not sure if this will show, but let's see. A detailed exit code. What do we mean by that? Okay, it's not. Oh, here. I just saw it somewhere. Okay. So return detailed exit code when the command exit. This will change the meaning of exit code to 0. If diff is empty, that means if there are no changes. If the Terraform plan file has no changes, that means it is 0, succeeded. If it is errored 1 and 2, with 2 also it is a success, but that means there is a difference between desired state and the actual state. So that means the drift is detected, right? And that is what this code is doing. If sorry, not this one, this part, if the exit code is 2, that means the drift is detected. So what we need to do, we are again using that fs import and then setting it as a constant for plan output, reading the file plan output.txt, the one that we got earlier, right? And then um, we are printing this message, right? And then show plan, all those details we are printing, and then finally we'll be applying the changes. So this is just, you can go through it. I'm not going to explain each and every line of it, but you can go through it. I mean, you can take the help of LLM, or my favorite is this one, like GitHub Copilot. It will explain it to you, whatever you want. So it will check that, and then what it does, it will auto fix the drift. That means it will override the changes from the GitHub code. Okay, so it will do Terraform apply auto approve, and apply output will be in a separate file and continue on error. Then it will also notify Slack, right? In the Slack message, based on the condition, if they are true, it will send the message. It will post, because it's a webhook call, right? So it's just doing a post request over there, and with this message, with this header and text and so on, right? So it will send all those details, and then if it has failed, then this is what it will do on the failure. Okay, and update issue on success, like if it is exit code is 2 and the steps apply outcome is equal to success, that means if the drift was detected and the apply was successful, then it will update the GitHub issue as well, and it will, so here this is creating the comment, and this is updating the issue and marking it as closed. Okay, and then it will publish the drift summary. Then it will close old drift issues as well where exit code was 0. And if there is no drift, then as I've told you, it will just say no drift detected and it will put that in GitHub step summary. Okay, so that was drift detection, and destroy is similar. It will just destroy the environment. It's all like everything is similar, so you can go through it. Let's go back over here, and we have the infra ready. Like, so let's try to make some changes and let's try to test this out. Okay, yeah. So let's go back over here in day 30 repository, which is over here. Okay, lessons and day 30. Inside code. Okay, let's try to make some changes. So first let me just check out the dev branch. So git checkout dev. Okay, already on dev, that's good. Now let's make some changes and let's go to main.tf. It doesn't have much. Let's backend.tf. Okay, this is just the backend. Let's go to ALB. Let's update the tag of load balancer, right? In the app load balancer, let's keep it as app load balancer 2. Okay, just a small change. And let's go back over here. In fact, okay, yeah, first let's do that and then we'll test the drift detection. So you can go over here. Here's the tag, which is app load balancer. Okay, so let's make this change on dev and then let's do a git add. Okay, git status, which is one file alb.tf. Okay, let me just pull it up and then git commit -m test the dev workflow. Okay, and then git push origin dev to push the remote dev branch. Okay, changes have been pushed. Let's go back over here. Okay, yeah, over here. No, in the GitHub repository, I think I have closed it. That's okay. Okay, and yeah, and let's go to actions. See, the workflow has been triggered and it will make the changes. You can click on that. And that was the first job, Terraform plan. This is the second job, Terraform apply. And you will see all the details over here, like the output of each and every stage. So these are the different stages: Terraform init, download plan, check if exists, check the plan exists, and then Terraform apply. And once, so it is, you see, it is why it is modifying ASG. Yeah, maybe there is something that it has to modify even after we did not make any changes, but you can verify Terraform plan if you want. Now it is applying the changes to load balancer, which is what we want. So once it is applied, we should see the updated tag over here. See, it's done. App load balancer 2. So that's just the normal change that we have, like the normal GitHub workflow that we have seen earlier as well. Now we need to detect the drift. So for that, actually not detect the drift, we need to test the drift. So let it complete. Okay, is it complete? Yeah, this is complete yet. Okay, and oh, still it's not marked as complete. Okay, now it is completed. If I click on that, yeah, it is completed. Now over here, let's make some change. Okay, let's see how can we update the tag. Why I'm adding, because it doesn't need to recreate the resource and it will be fast. So that's why, otherwise you should be doing something else. Load balancers. Okay, over here, click that and tags. Okay, so manage tags. Let's update the tag. So let me make it Terraform. Okay, managed by, not Terraform, managed by 𝗔𝗀𝗠. Now what it should do, because we have that drift detection workflow continuously polling between desired state and actual state after every 1 minute as per the cron, it will detect, I mean it should detect, if there is any difference between the desired state and actual state. It will find that someone has made the changes directly from the UI or from the console or not from the Terraform, and it should revert the changes. And why, like why, what is the use case of this? I'm going to explain it to you while it takes it time to run and to detect the change. So why do we do that? Like let's say in an organization, what happens when you work on something? Okay, so there are dedicated teams for each of these things, right? So there is a team dedicated for networking resources, there is a team to maintain and manage dev environment, for production environment there is a separate team, right? So each team has certain roles and responsibilities, each team has certain level of permissions on the environment, on the organization, and so on. And ideally every single change that has been made should be tracked, right? And it should be as per the desired state that we have set, and that is why we use Terraform as well, right? If you go back to day one video in which I have explained why do we need Terraform, in that I have explained with multiple examples why do we need Terraform. So with that in mind, we need to track every single change. If we make the changes from UI, how do we keep history of it? Like we have to go and check the CloudTrail logs and multiple other places. It will be a complicated process, right? So, and if it's a prod environment, let's say, no one should be able to make any changes without a proper change request, without a proper CR, what we call it, right? So or proper incident, we should have a maintenance window, right? So to block all those changes, first, like not everyone should have permission to make the changes, that's first thing. Other thing is, to avoid any accidental changes, we implement drift detection so that only the GitHub repository, only the code in the GitHub repository will act as a single source of truth. And this is what we are doing. Now I think it's been few minutes already. Let's see if it has been triggered. Okay, it's not been triggered. Let's see Terraform drift detection workflow, and it's not been triggered. The workflow, okay. It says the workflow has a workflow dispatch event trigger, and use the workflow from dev branch and run the workflow. Maybe, okay, no, so this is the manual trigger. We should not trigger it manually. Let me check why it has not been triggered. Okay. I think I found the issue. Let's test this out. This has been configured to trigger only on the default branch, which is dev, right? Which is main. So let's just add this, like push on both the branches. Like whenever there is a drift detectors on branch, main, or dev, you should do that. Should trigger this. So let's commit the changes, and now either we can manually push it or we can try to make any other change. Oh, it actually detected first. Yeah, it detected twice. Okay, no. So this is Terraform CI/CD because we made some changes in dev branch. And this one is the drift detection because it detected the drift. Like there is a change between your Terraform plan and Terraform, like the desired and the actual state. And now it is saying apply Terraform changes to fix the drift. So let's see that. Okay, so I think the job has been completed, which says, let's see what it did. It says run this and drift detected and auto fixed. And these are the variables that it set. Okay, it skipped the other steps, which is not valid in this case. And then in the complete job, it has just cleaned up the orphan processes. Here is the Slack notification as well. We'll check that. But first, let's test the drift. Okay. So the load balancer tag we updated. We made it managed by Piyush. Let's refresh. Oh, it's still managed by Piyush. So what changes did it make? Okay. Environment is production. Oh, because default environment it took as production. Let's check the Slack notification as well. Here's my Slack channel, and yeah, here is the Slack notification. It says branch dev applied the changes, detected drift, and it says view run as well from here. So this is basically the logs that we just see, and it says drift detection summary. So it says Terraform is detected, fix, let's check the logs. And okay, what I need to check is where did it detected it, like what changes have it analyzed. Let's see this Terraform plan. Okay, says desired capacity will be updated from 1 to 2, and yes, so tags will be managed. First it will delete this tag, and then it will update it from that to from Piyush to Terraform, right, which is what we have in the configuration. And let's click on this analyze drift. Now it ran this particular script. There is no output for that. There is just the command for it. It detected it and it's there in the plan as well, but when it applied the plan it's not there. Why? Let's see. Terraform apply auto proof no color. Oh, why there is no Terraform? um I think it's because it's not using the same backend. I believe that's the issue. Let's check. There is only one load balancer, right? Okay. What's that? Okay, yeah. Update issue, and let's check the GitHub status as well. Is there any issue for it? There is state should be closed. Yeah, here is the issue that it closed. Let's check this as well. Says show plan. Okay, this is the plan, and yes, the changes were to it should be from this to Piyush. That that change should be made, and it says like it added the comment drift has been remediated closing issue, and it actually closed the issue. GitHub action closed this. Now if we go back over here in the environment, let's click on this, go to tags. I still, oh, it is. I'm not sure why it was not getting reflected earlier. So now you see it's managed by Terraform. It has made the changes. So it override the changes, whatever we made from here from the UI, it override the changes with what we have in the GitHub repository. And what we have in the GitHub over here, we have this one tag for load balancer. It should have some default tags as well, and that is why it was showing managed with Terraform. So let's see where have we configured it. You see default tags, and this is the one managed by Terraform. So that is why it was there. So this is the drift detection that we wanted to test. Now there are some more steps that you can try it out. So if you go to the GitHub repository, because those are simple steps and you can test it out without any issues. So I want you to do that. So if you go to lessons and day 30, inside that, you see we tested this drift. Now what you can do, the changes are not okay, changes are not in the main branch, it's there in the dev branch. I did not merge the branch yet. So this is what you can do. Test the drift, which is what we already did. Now watch in GitHub Actions. After dev succeed, merge to main. Now merge your dev branch to the main branch so that it will create the infra from production as well. And when it creates the infra for the production, you will add the approval button in the GitHub action. Once you approve, it will provision the resources. And then you modify a resource manually using AWS CLI or from the AWS UI, and it should detect the drift and it should apply the changes. It should revert those changes. So try it out and don't forget to destroy. Destroy also we can do that with this GitHub action pipeline. Let's see. Terraform destroy. And let's run the workflow. Select the branch. Branch is dev. Environment to destroy is dev. And then here is type destroy. Run workflow. So let's see. Yeah, it's in progress. Okay, so it should destroy completed so soon. No, it says no objects to be destroyed. Again, I think it is also working on the default dev branch. So let me fix that as well. So if we go back to destroy this file and let's select the branch to dev, select this. Okay, on. So these are just the workflow, like the inputs, but what we need is, I think it was, oops, what we added over here. Did we add over here? No, right? Okay, so let's take it from the Terraform YAML. So what we need is this. Oh, no, it should not be on push or this. It should be, this should work. So we are setting default branch as dev, setting options as dev, confirm destroy true, and this Terraform destroy. Now this is dev. Oh, over here. So there is a mistake. Is this the same file? Wait, this is day 27, right? So we should have another for destroy.yaml. Okay, this is the one. Now, did we run this or the other one? I don't remember it now. Let's go back. Let's go back to actions and let's run Terraform. Okay, so there are two Terraform destroy. There is one Terraform destroy. For day 27, it is picking. I think because I created, not we, I created the file with the same name. That is why it is not picking it. So let's make that change in the dev GitHub workflows and destroy.yaml Terraform destroy day 30. Let's make the change over here and this should trigger the destroy pipeline. If not, we can manually trigger it as well now. So first it detected, it triggered the, okay, Terraform CI/CD, this. Now let's trigger the Terraform destroy. It's still not coming over here. Let's hit refresh. It should come as the new workflow, right? Terraform destroy day 30, like what we configured right now. So let's see why it is not coming. So okay, no, not on the main branch, dev branch. So destroy.yaml, destroy day27.yaml. Okay. And if we check this, Terraform destroy day 30. Yeah, changes are there in the dev branch. So why that workflow is not visible over here? Terraform destroy. Oh, no. These are the other runs. Drift detection. Terraform CI/CD. And I'm not sure. Maybe I'm sleepy. It's almost 1 o'clock. Yeah, I've been up for past, I'm not sure, 20 hours or so. My mind is not working right now. Maybe it's just a silly mistake, and maybe you are able to find it out. So if you do, let me know as well what mistake I am making. So what I did, let me check just one more time. If not, I'm just gonna close it. Okay. So in the dev branch, I have a GitHub workflow with the name destroy.yaml. There is no other file with the same name. In this file, we have the file name as Terraform destroy. Maybe I'll just create a new file with this content. Let's do that. Tf destroy.yaml. Okay. In the dev branch, let's commit the changes. Okay, and go to actions. And still not here, right? It triggered all, like, both of the pipelines, but why not the workflow visible over here? Maybe, I'm not sure. Yeah, I need to go and get some sleep now. If you find it out, let me know. If you don't, then I mean, try it out. I will also try it out. Okay. So yeah, that's it from this video. I hope you found it valuable, and this marks the end of this wonderful series. Thank you for all the love, all the support that you have shown. I admire your patience. I like, because the videos were 1 hour in length or more than 1 hour in length, and you patiently sit there and watch. And why I'm saying this now after the end of the video, because I wanted to say thank you to each one of you who are still here even after we have completed the video, even after we have completed the series. So thank you so much, and keep learning. Let me know in the comments which next series you want me to work on. I will start probably from next month. I will also create a poll on my LinkedIn, social, like all the social medias, and let me know which series I should be working on next. And the most requested series, I will definitely create a playlist on that. And let me also share, like, share your feedback also about this series. What did you like about this series and what you did not like, so that I can make those changes from the next series. Like, from my side, what I feel like I gave too much in this series. Like, there are around 7 8 real time projects, 10 mini projects. Maybe it was not necessary, maybe it was little too much considering the scope of Terraform. If you also feel the same, let me know, so that from the next series onward, whatever series we work on, maybe I focus more on the concept and create one or two real time project, but it's all in one project, like one big complex project if even it's gonna take 3 hour for the recording, 4 hour, doesn't matter. If you want that, then let me know. If you want to keep me to keep the same format, then also let me know. Yeah, do share your feedback. And this is how we work, this is how we improve day by day. It's a learning for me as well every time. And yeah, that's it. Thank you so much. I will see you soon with the next video. I hope you have a good day. I hope you have a good learning experience. Happy learning. Signing off now.